And number 4 from our paper 1 from May June 2017 is saying the diagram shows a circle with radius r centimeters and the center O. Points A and B lie on the circle, and ABC D is a rectangle. Angle AOB is 2 theta radians, and AD is equals to r centimeters. Express the perimeter of the shaded region in terms of r and theta. They told us that ABCD is a rectangle like that, meaning the line that I've just drawn is equal to DC, right? And AD is also equal to BC, so this will be R. So for us to get the perimeter, we'll need this, the length of this arc, and we'll also need the length of DC, which we can get by getting the length of AB, right? And for us to get the length of AB there, we can divide this into 2 so that we know it's 2 theta, so this will be theta and theta. And since this is also r, let's name this x, like one part x, right? And this is opposite of theta, and the r is the hypotenuse, so we use sine. So we're going to say sine the angle, which is theta, is equals to our x over r. And for us to get our x, we're going to say r sine theta is equals to x, meaning this x is r sine theta, and this part as well will also be r sine theta. So together they give us 2r sine theta. That's for DC, right? And for the length of the arc, we know it's r theta, right? That's how we get the length of the arc. So expressing the perimeter, which is the distance right around the shaded region, we're going to say r plus 2r sine theta plus r theta. So it's r plus 2r sine theta plus r theta, which will result in 2r plus 2r sine theta plus r theta, like that. And that should be the perimeter of the shaded region in terms of r and theta. So let's move on to the second part. There's a lot of space. In the case where r is equals to 5 and theta is equals to 1 over 6 pi, find the area of the shaded region. We're now being asked to find the area of the shaded region. So for us to get that, we will need the diagram. I'll just rub this out. Right. We want to calculate the area of the shaded part. And we know this is a rectangle to begin with. So we're going to get the area of this rectangle first, right? Get the area of the rectangle. Then we're going to get the area of this whole sector right here, right? And once we get that, we're also going to calculate the area of this triangle which is inside. Then we're going to say area of this sector minus area of this triangle, so that we get this area right here. And we're going to say from the area of the rectangle, right, we're going to subtract area of this part that I'm shading here to get the area of the shaded region, right? So for area of sector, we're going to say half r squared theta, and it's half 25 because our r is now 5, we were told, and our theta is now 1 over 6 pi. That's how we're going to get area of this whole thing. And for the area of that triangle, we're going to use half AB sine theta, and our A and B O equal to 5, so it's half 25 sine 1 over 6 pi, right? Then we're going to say area of a sector minus area of the triangle to get this area. Then we're going to say area of rectangle minus that area that we're going to get from saying this minus this, and that should give us our answer. So let me just punch these into my calculator. Half of 25 sine 6 pi. So this gave me 6 and 1 over 4. This is the area of the small triangle, and area of the sector is this right here, which is 25 over 2 times 1 over 6 pi, like that, which gave me 25 over 12, like that. So for us to get the area of this part, which I'm shading just now, is just 25 over 12 pi minus 6 and a quarter, which is 6 and a quarter, which is 0.295, right? That's the area of this small region, right? Then area of this rectangle, remember this is 2r sine theta, this DC, so we're going to multiply that by r, right, to get area. So it will be area of rectangle, it will be equals to r times 2r sine theta, like that, and that will be 2r squared sine theta, and we know r is 5 and theta is 1 over 6 pi, so it's 2 times 25 from 5 squared times sine 1 over 6 pi, like that, and that should give us 25 sine 1 over 6, and that gives us 25. So for us to get the area of the shaded region, now we're going to say 25 minus this value right here. So it's 25 minus 0.295, and that's 24.705 square centimeters. So if it is to say you're in an exam, you have to put all this working on the space provided here for you to get marks without asking questions or having to explain yourself. Oops, that's it for part 4. This is it for part 4. I hope I've made it clear enough.